We're finally ready to implement our interpreter for object-oriented curly, and that means we need to consider each of our expression cases given some value for this in arg. The first few are easy because num-e is to num-v, and plus-e involves num-plus on recursive interps, and multi involves num times on incursive reterps. Those are pretty much the same as before, we just have to pass along this in arg. This e is also straightforward because when you evaluate this e, you just return what we passed in to be this val. And similarly, arg e, you just return arg val. This is in contrast to looking in the environment. We just have the two possibilities right there. So the more interesting case is object e, get e, and send e. And for object e, we have fields and methods. For the fields, it's a list of fields, so we can map over it. These are where we need to evaluate initialization expressions, but the methods we can leave alone. So if we look at each field f, remember it's a tuple of a name and an expression. So let's say name is the first of that tuple, and exp is the second of that tuple. And then we've got an expression, so let's interpret. We interpret the expression, passing along this val and arg val. This gives us a value, and what we want to do with that value ultimately is put it inside of an object. That is, we're trying to return an obj. And when we return an obj, the methods stay the same, but for the list of fields here, we need the field value combined with the field name. So we put it back together with values. So that's the complete object-e interpretation. Just like lam-e evaluates to a closure, object-e evaluates to an object, and the only thing we interp is the initialization expression for the fields. Let's look at get-e next. We have an expression that should evaluate to an object, and we have a field name. This is not an expression. It's like when you say o.x in Java, the x is a name. It's not an expression that you interpret. So object expr is an expression, so we interpret, and we get some object back. Hopefully we get an object back. We'll have to do a type case to make sure it's an obj and not a num-v. But if it is an obj, then we have a list of fields and a list of methods, and we want this field name. So we look in fields with that field name using find. And when we get a value back, that's exactly the value we wanted. The last case is send. So for send, we have an object expression. That is, an expression that should produce an object. We have a method name. That's not an expression. It's just a method name. And we have an expression for the argument. So those first two, the first and third, object and arg, those are expressions, so we can interp them. We get a value back for the object that we're sending to, and the value for the argument. Hopefully obj is an object, but we'll have to double check. We'll have to do a type case on value and make sure we get an obj. If we do get an obj, then we've got fields and methods, and what we care about this time is the methods. We want to find this method name in those methods. So we do that, and what we get back is an expression that is the method's body. Right? Because a method pair is a tuple that combines the name with the body expression. So we want to start interpreting this body expression, but instead of passing along this val and arg val, as we interp that body expression, we pass along the argument that is the target of the method call. And we also pass along arg val, the one that we replaced actually, not the one that was given. The value of the argument expression becomes the arg val for the body expression. If we didn't get an object, then we complain, and that's all of method sending.